Hello children, myself Prasad. I am taking maths and my tuition center is at Kowdiar, by name IMAT Maths Tuition. So all of you, welcome to my YouTube channel. Today we are going to see a very important topic in maths. This topic is there for both ICSE as well as CBSE. Both the syllabus are dealing with this particular chapter, and this is a very important chapter not only for 10th standard but also for higher classes. And this is an important topic even for competitive examinations after 12th. So children, when you're preparing this particular chapter, you must study this chapter in depth. So shall we start this chapter? The name of this chapter is Arithmetic Progression, which we shortly write it as AP. So let us study what is arithmetic progression. First, let me just introduce one term called sequence. You have heard of this term called sequence. What is a sequence? എന്താണ് ഒരു സീക്വൻസ്? സീക്വൻസ് എന്ന് പറയുമ്പോൾ just a set of numbers which may or may not have an order. Normally when we define a sequence, we say it follows an order, but actually sequence may or may not have an order. Say for example, I write an example like this: 1, 2, 3, 4, etc. This is a sequence of numbers. Suppose I say sequence like this: 0, 1, 1, 2, 3, 5, 8, etc. This is also a sequence. But children, those who are in touch with maths, those who like maths, those who are interested in maths must know this particular sequence. The sequence is called Fibonacci sequence. So these types of numbers which may or may not have an order is called a sequence. Now, the name of the chapter is Arithmetic Progression. So first, we need to know what is a progression. So I just introduced this term called sequence. Now, let us see what a progression is. How is it different from a sequence? What is a progression? See, progression is nothing but a sequence of numbers that follow an order. A sequence of numbers that follow an order is called a progression. What do you mean by saying following an order? It means that if I give you 3 or 4 numbers of a sequence, you must be able to say what the next number is. Say for example, if I say a sequence like this: 1, 2, 4, 8, 16. I think now you have got the idea what can be the next number. The next number will be 32. The next number will be 64 and so on. So this sequence follows an order. So you can call this sequence as a progression. Say for example, 2, 4, 6, 8, 10. You might have got the idea what will be the next number. Yes, the next number is 12, the next number is 14 and so on. This sequence follows an order, so you can call the sequence as a progression. So what is a progression? A progression is a sequence that follows an order. There are many types of sequences, or in other words, there are many types of progressions, of which one is arithmetic progression, which you are going to study this year. Both CBSE and ICSE students require this. What are you going to study about arithmetic progression this year? I'll tell you what all points you need to study about arithmetic progression this year. So the first thing that you need to know is, what is an arithmetic progression? First point that you need to know is, what is an AP? Right? You know it's a progression, which means it follows an order. So if it follows an order, there are some formulae connected with this progression. The first one that you will study is the general form of an arithmetic progression. Then you will study what is the nth term of an arithmetic progression, nth term of an AP. And then finally, this year, you will study how to find the sum of the terms of an AP. These are the points that we will be covering this year in this particular topic. And if you know these terms properly, then you can go to any level of this particular chapter. Okay? Right. So now let us see what is an AP. What is an arithmetic progression? Just see. As I said, a progression is a sequence that follows an order, right? Now let me take an example here. I'm going to give you an example that follows an arithmetic progression, and then I'll explain what this specialty is. Say for example, I took one example before. I'm taking the same example here: 2, a 4, a 6, 8, 10, 12, etc. You see this progression. You see this progression. Here what you see is the difference of 4 and 2. The difference of 4 and 2 is 2. The difference of 6 and 4 is 2. The difference of 8 and 6 is 2. The difference of 10 and 8 is 2. What you are seeing here is, it is an increasing sequence which increases by a constant. A progression which increases or decreases by a constant is called an arithmetic progression. Are you following what I am saying? A progression is said to be in AP if that progression increases or decreases by a constant. See, in this example, that constant is 2. We call this constant by a name called common difference, which we will be using a general letter for it, D, small letter D. So what is an arithmetic progression? A sequence that increases or decreases by a constant is called an arithmetic progression, and this constant is called the common difference. Say for example, I take another example. See, I take example 30, 27, 24, 21 and so on. See this progression? Take the difference of the consecutive terms. 27 minus 30, it is minus 3. 24 minus 27, it is minus 3. 21 minus 24, it is minus 3. What are you seeing? This is a decreasing sequence, and it is decreasing by a constant 3. Right? Or you say the common difference is minus 3. Such a progression which decreases by a constant is called an arithmetic progression. So now let me sum up this what I said. A progression which either increases or decreases by a constant is called an arithmetic progression. Hope you understood this one, right? So this is the first point. What is an AP? So I've given you a brief idea about what an AP is. Right? Okay. So if you want to check whether a progression is in AP, what will you do? If a question comes, find whether this progression is in AP or not. What you need to do is just take the difference of the consecutive terms. And if you see that the difference is the same, you can call that progression as an AP. Right. So now let us go to the next concept of this particular progression. See, I'll just take this example. I'll just take another example. Say, let me take the first term as 3. Let me take the next term as, say, 7. Let me take the next term as, say, 11. Let me take the next term as, say, 15, etc. See, you're seeing this progression. This is an arithmetic progression, yes or no? Here the first term is 3. The difference 7 minus 3, 4. 11 minus 7, 4. 15 minus 11, 4. So you see that the difference is the same. So you can call this as an arithmetic progression. Let me just denote the first term by letter A, and let me take, here it is 3. And what about the common difference, D? The difference between these two terms is 4, right? See the terms of this progression. See the terms of this progression. I can write every term of this progression in terms of 3 and 4. How? Let me just see. Let me just write this. The first term is 3. The next term is 7, which can be written as 3 plus 4. The next term is, again you add one more 4 to this. You add one more 4 to this, you will get the next term, that is 3 plus one more 4 means it is 2 times 4. 2 into 4. Again add one more 4 to get the next term, that is 3 plus 3 times 4, etc. Isn't it? 3 into 4 is 12. 12 plus 3 is 15. See, you can build up a arithmetic progression. You can build up an arithmetic progression if you know the first term and the common difference. This is what you're seeing here. So if 3 is the first term and 4 is the common difference, see the terms of this progression. The first term will be 3. The second term will be 3 plus 4. The third term will be 3 plus 2 times 4. The fourth term will be 3 plus 3 times 4 and so on. So let me say the next important point. If I say the first term is A and the common difference is D, can you build up the arithmetic progression? Let us see. The first term is A. How do you say the next term? You just add the common difference to it, A plus D. What will be the next term? Another one more D will be added, so A plus 2D. One more D will be added, A plus 3D. One more D will be added, A plus 4D. And it goes on. This is called the general form of an arithmetic progression. So let me wind up. If A is the first term and D is the common difference, then the general form of an arithmetic progression is A plus D, A plus 2D, A plus 3D, A plus 4D, etc. Okay? So children, this is the general form of a geometric progression. A plus D, A plus 2D, A plus 3D, A plus 4D. Now let me come to a very important formula from this section. See, let me just take the first term as A1. So here the first term is A in this general form. The second term, let me take it as A2. See, what is the second term here? It is A plus 1 times D. The third term as A3, it is A plus 2 times D. The fourth term is A plus 3 times D. See, are you getting an order here? The first term is A, the second term is A plus 1 times D, the third term is A plus 2 times D, the fourth term is A plus 3 times D. So if I ask you, what will be the 20th term of this general form? The 20th term, won't it be A plus 19 times D? Yes, that's it. What will be the 25th term? 25th term, isn't it A plus 24 times D? So likewise, now you can say any term of a geometric progression in the general form. So if you have got an idea, now please tell me, try to say what will be the nth term. See, AN denotes as nth term of an AP. So what will be the nth term of an AP? Can you say? See, the first term A, second term A plus 1 times D, third term A plus 2 times D, fourth term A plus 3 times D. So what will be the nth term? Isn't it A plus n minus 1 times D? Yes, so this is the first and the most important formula from this topic, the nth term of an arithmetic progression. So please note down this formula. Nth term of an arithmetic progression is given by an is equal to a plus n minus 1 into d. Let me make it a little more clear. An stands for nth term. A for the first term. N says number of terms. D says the common difference. So let us do one question. Let me try one question based on this particular formula. Now this is a very good formula for this particular chapter. Term. Children, just see this particular question. If 10 times the 10th term is equal to 15 times the 15th term, find its 25th term. So what is the key concept for this particular question? The key concept is you must know what is the nth term of the AP. So here we are dealing with AP. So it is the 10th term of AP equal to 15 times the 15th term of AP. What is the nth term? We have studied it is A plus n minus 1 into D. Okay, so what is the condition given? 10 times the 10th term. So 10 times A10 is equal to 15 times A15. Am I right? So 10 times, how do you say the formula for 10th term? You know, nth term is A plus n minus 1, 1 less than this. So what will be the 10th term? Isn't it A plus 9 times D? And it is equal to 15 times what? A plus 1 less 14 times D. Right? What is asked? We need the 25th term. Can you just tell me the general formula for the 25th term? Yes, it is A plus 24 times D. Okay, just see here. Now let us simplify this. So when you open the bracket, it is 10A plus 10 into 9, 90 times D is equal to 15A plus what is 15 into 14. Let us find out what is 15 into 14. 15 into 14, 5 4s are 20. 2 carry over, 4 plus 5, 9, 9 plus 2, 11. 1 into 1. So that isn't it 210? So this is 210. Okay. So now let us simplify this. I'll take this 10A to the right side. This is 210 times D. So I'll take 10A to the right side. All the terms, both the terms, let me take it to the right side. So here it is 15A. What is 15 minus 10A? Won't it be 5A? Right? Now let me take 90 to the right side. So 210 minus 90. 210 minus 90. Isn't it 9, 11, 2? Isn't it 120? D is equal to 0 because all the terms have gone to the right side. So this side will become 0. So it is 5A plus 20D equal to 0. Am I right? So see this equation once again. You can divide throughout by 5. So this is A plus 5 2s are 10, 5 4s are 20, 24D is equal to 0. A plus 24D is equal to 0. What is asked? The 25th term. How do you say the 25th term? Isn't it A plus 24D? See, we have got that. So therefore, you are getting the answer. You have got the answer. A25 is equal to 0. Got it? So this is a very good question from this particular topic. Right? So see here, I'll tell you the short trick also. Just see here. 10 times the 10th term, 15 times the 15th term. What is 10 plus 15? Is it 25? The question asked is 25th term. So for any question of this type, the answer will be 0. No doubt, you just simply take it as 0. No doubt, it will be always 0. So if I say 20 times the 20th term is equal to 25 times the 25th term, can you tell me the question and the answer? Yes, the 45th term, A45, 20 plus 25 will be 0. Yes, no doubt it will be 0. Children, so this question is clear. So there are lots of questions based on this, similar to this. Try questions more on this and see whether you can do the problems from this. Okay, so we'll see the next section in the next class. Till then, goodbye.